Hi there, my name is Max van Wyk de Vries. I'm a PhD student just finishing up at the University of Minnesota. And I'm going to be talking about some work that we've been doing reconstructing the eruptive history in southernmost Patagonia. There's a number of very interesting factors converging on southern Patagonia. Firstly, it's home to the largest ice masses in the southern hemisphere outside of Antarctica, the southern and northern Patagonian ice fields. It's also home to a triple junction with a subduction of the Chile Ridge, which unzips underneath Patagonia, forming a slab window, which underlies a large portion of the region. And it's home to a large number of active volcanoes as well, with the southern volcanic zone present to the north of this slab window, and the austral volcanic zone present to the south of this slab window. It's this austral volcanic zone that we're going to be primarily focusing on here. There are four main active volcanoes within this zone: Lautaro, Aguilera, Reclus, and Berni. The northernmost of these three are located within the southern Patagonian ice field itself, and partly due to their remoteness, and partly due to their presence in a very low preservation environment, with deposits being carried away by fast-moving ice, very little is known about their recent or old eruptive history, which means we have a fairly poor assessment of how active these volcanoes currently are. So our objective in this study was to study the sedimentary record of a nearby proglacial lake, Lago Argentino, which is located downwind of the most active of these volcanoes, to evaluate the recent eruptive history in southern Patagonia. So in 2019, we traveled down to Lago Argentino and collected approximately 100 meters of core from all the major depositional environments of this lake. But there's many interesting factors within this sediment that I want to tell you about two in particular. Firstly, that the sediment is varve, which means it's composed of alternating light and dark laminations with an annual cycle. We can use this to build a high-resolution age depth model for each core. And secondly, that there's a large number of tephras spread throughout this lake. There's a total of about 100 tephra layers spread throughout our data set. We used a semi-automated varve counting method in order to count this very large number of varves and build an age depth model for each core. I'm showing you an example of this to the left with a core with 3 tephras in it, 2 extremely fine tephras, about 1 millimeter thick, and 1 thicker one. And we're able to count the varves above and between these tephra layers in order to determine their age. And the semi-automated varve counting model is also able to determine the uncertainty in this varve counting age. Finally, in order to calculate the composition of each of these identified tephra layers, we used a single grain tephra glass analysis on a microprobe. We measured a minimum of 15 individual glass shards for each tephra layer, for a total of around 1,000 individual glass shard measurements. Showing you a few examples of what some of the tephra glass grains look like on this slide. There's quite a variety of them. I'll show you the results. Here is a CAST diagram of the average composition of each of the 57 tephra layers. You can see that the majority of our results plot within the rhyolite field with a minor subpopulation in the trachytic field. I'm going to zoom in on that major composition. See really a large cluster with no clear subpopulations here, perhaps a hint of 2 separate clusters. I've plotted 2 important populations, one in blue, which is from the A1 tephra horizon, which is a known regional marker horizon from Aguilera volcano, and the other 3 red points are tephra layers that were previously analyzed in another study and are known to be from Lautaro. So we're able to use these to differentiate between Aguilera and Lautaro. This can't really be done on a TAS diagram. However, if we split out different elements, here titanium, potassium, and phosphorus, we can see two separate subpopulations appearing much more clearly. Firstly, we still have these four outliers that were previously in the trachytic field. These match fairly closely with the composition of the southern volcanic zone to the north. We think these are most likely from Holocene. And this single cluster in the rhyolitic field is now split into two clusters, one representing Lautaro and the other representing Aguilera. To remind you of the location of each of these, the green dots on this map show the southern volcanic zone volcanoes. Hudson is the southernmost of these. And the orange and blue dot show the locations of Lautaro and Aguilera. We can now, using this information, split up the timing into the timing of different volcanoes. The uppermost plot shows the eruptive history of this region from previous literature. You can see that there's very few eruptions recorded. Actually, there's a few recent eruptions from Lautaro, a single eruption of Aguilera around 3,000, 4,000 years ago, and otherwise nothing. We, on the contrary, find about 30 eruptions. The majority of these are either from Lautaro or Aguilera in Lago Argentino, with Lautaro being particularly active over the past 500 years, and Aguilera being much more active between 1,000 and 5,000 years ago. We can see that there is some correspondence as we see a cluster of eruption from Aguilera around 3,000 years ago. However, we don't see a single eruption. We instead find a cluster of more than 10 eruptions around this time period. One of the important questions that we're still working on is whether deglaciation in the Patagonia can increase the eruptive frequency of these volcanoes. We're currently comparing ages of these eruptions with known ages of glacial advance and retreat from moraines to identify whether there's any correspondence there. And we're also working on understanding whether Aguilera and Lautaro are susceptible to increased eruptive frequency due to the ongoing extremely rapid ice loss in Patagonia. To sum up what we found, we used the VAV and TEFRA record from Lago Argentino, an extremely large proglacial lake in southern Patagonia, to evaluate recent volcanic activity of the poorly constrained austral volcanic zone. We trace three distinct TEFRA compositions, the Aguilera, Lautaro, and Hudson volcanoes. And we show that Lautaro and Aguilera have erupted at least 29 times over the past 5,000 years, which is much higher activity than had previously been identified. Thank you.